We are starting our last section of Chapter 2. We are going to take today what we have learned about solving equations and we're going to apply it to things like formulas, okay? And our goal for today is to be able to rearrange formulas to highlight a quantity of interest. Basically, that's a fancy way of saying we're going to take a formula and we're going to rearrange it to solve for something besides what the original formula was for, okay? Our brains are not going to like what we see today. It is going to look very weird to our brains. We like, if at all, one variable. We're going to see lots of variables today, and it's going to look very strange to us. For those of you that have already claimed that letters shouldn't be mixed with numbers anyway, you're really not going to like this because it's going to be mostly letters. But that's okay. We can do this. We're going to use what we know about equations. Now, we're going to take a formula like this, okay? P equals 4s. So I'm going to rewrite it here where it's big enough that I can do something for it. This is a formula. And they tell me right here that P is the perimeter of a square and S is the side of a square. So they're telling me here that the perimeter of a square is 4 times the length of a side. Do you agree with that? Yes. If you know the side of a square, you can multiply it by 4 since all the sides are equal, and you get the perimeter. This is called a literal equation. That means basically it's got lots of variables and not just one, okay? Now, right here they tell us what they want us to solve for. We want to solve for S, okay? So my first goal, what they tell me up here in my instructions, is for each equation, solve for the given variable. So we're going to take this equation and we're going to solve for S. We're going to isolate S. We're going to use our equation rules. We are trying to isolate S, okay? Now, we need to ask ourselves, what's in the way? What's keeping S from being isolated? This 4, okay? What's the operation between the 4 and the S? Multiplication. What's the inverse operation to multiplication? Division. So we are going to divide both sides by 4, okay? Now, these 4's cancel, and we get S equals P over 4. Look weird? Yes. Have we isolated S? Yes. That was our goal, was to isolate S since that's what they told us to solve for. Okay? Now, once you get the hang of this, once you get some practice, that part won't be so bad. Here's the part you're probably going to grumble about a little bit, and that's okay. It says explain the meaning of the new equation. Here's what they want with that. The original equation says the perimeter of a square is 4 times the side of the square. What is this new equation telling us? What is this new equation telling us? Well, it isolates S, so it's telling us that the side of a square is what? What does this over here mean? The side of a square is P over 4. So they're telling us that the side of a square is its perimeter. Spelled that wrong. Perimeter divided by 4. Okay? So basically they wanted us to take this equation and write it in words. The side of a square is its perimeter divided by 4. Okay? Let's look at another one. All right, here they give me the formula. V equals 1/3 pi r squared h. Okay, they tell me what all this means. V is the volume of a cone, r is the radius of the base of the cone, and h is the height of a cone. This is the volume formula for a cone. Now, what do they want me to solve for? They want me to solve for h. So I need to isolate this h here, okay? Now, a couple of things I notice. All of this is multiplied, right? This is 1/3 times pi times r squared times h. So my inverse operation is going to be division. But I want to handle this 1/3 first. How do we handle a fraction in front of something when we're multiplying? What do? Do you remember? We multiply both sides by the reciprocal, okay? So I'm going to multiply both sides by 3/1. I'm going to flip that 1/3 and multiply both sides by the reciprocal. Why do I do that? Well, now my fraction went away. So over here, I'm left with pi r squared h. Now, over here, 3/1 times v. Well, this is just 3, right? And what is 3 times v? It is 3v, okay? So I took care of my fraction. Now, my goal is still to get h isolated, because they told me up here I'm solving for h. I'm trying to get h by itself. Now what's in the way? Pi and r squared. What's going on between all three of these things? They're all multiplied, right? The inverse operation to multiplication is division. I'm going to do it all at once. I'm going to divide both sides by pi r squared. Since it's all multiplied, I can divide all at one time. So I'm going to divide that side by pi r squared and the left side by pi r squared. This cancels. I'm left with h equals 3v over pi r squared. Have I isolated h? Yes. Now, we need to put in words what this means, okay? So, look up here, what they tell me about h. They say h is the height of a cone. So, I'm going to say the height of a cone, because that's what I isolated, is what? How would I translate this, 3v? What does that mean? Well, v is the volume, so this is 3 times the volume, right? So I'm going to say is 3 times the volume then how do I translate the fraction bar? That's divided by, right? Divided by. Then, how do I translate this? Well, pi is just pi, right? And this is pi times the radius squared. Now, since this is in the denominator, I need to indicate that it's in parentheses, and I do that by saying the quantity. So it's divided by the quantity of pi, and you can just write the symbol pi because everybody knows what that is, times the radius squared. Notice how I put this all in words. This needs to be mostly words. Okay, watch again. The height of a cone is, that's your equal sign, 3 times the volume divided by the quantity of pi times the radius squared. All right, let's try another one. Now, at this point, if you want to pause the video, if you want to try this on your own and see how you do, you can. But since these are a little weird and a little new, I'm going to do these with you, okay? This says solve P equals 2L plus 2W for W. So we're trying to isolate W. P is the perimeter of a rectangle, L is its length, and W is its width, okay? So I'm going to take my formula. P equals 2 times the length plus 2 times the width. And I do a little cursive L so it looks a little weird. Now, I'm trying to isolate W. Notice W's over here. Do you see that this is sort of a two-step equation? I've got something equals something and then a plus this. This is sort of like a two-step. And I'm going to save the W to the very end. I want to move 2L. I want to move that whole thing. How do I move a positive 2L? Well, I'm going to subtract 2L. And I'm going to subtract it from both sides. Now, this is going to look weird, like a lot of what we've talked about. Right here, P minus 2L. Are those like terms? No. Can I combine them? No. So how do I write P minus 2L? Well, guess what? I say P minus 2L. That's the only thing I can do with that. All right? There's my equal sign. 2L minus 2L went away, and 2W's over here. Okay? Now, W's close to being isolated, but what's in the way now? That 2. What's the operation between 2 and the W? Multiplication. What's the opposite of multiplication? Division. So I'm going to divide this side by 2, and I also have to divide the left side by 2. But watch, I have to divide the whole side by 2, the whole thing, okay? Because I'm dividing both sides by 2. So these 2's cancel. I'm left with W. Now be careful over here. This is P minus 2L over 2. All right? Leave it that way. Be careful here. You cannot cancel these 2's because this 2 is stuck. It's stuck with the L, and it's combined with this P by subtraction. This up here is actually in parentheses, and you can't go canceling one thing in parentheses. That would be wrong. All right? We'll talk more about that later, but that's a bad thing. So we're going to leave this as our answer. All right? Well, now we have to put it in words. What are we saying here? I see W. W stands for the width of a rectangle. Notice I didn't just say the width. The width of what? The width of a rectangle is, okay? Now, how do I handle this over here? Well, remember this is in parentheses, so what words do I need to use to indicate that that's in parentheses? The quantity, right? So the width of a rectangle is the quantity of its perimeter, because P is perimeter, decreased by or minus or something like that, okay? Use one of your subtraction words, but not a turnaround word. Minus, how could I translate this? You could say 2 times the length, or what's another word we could use for 2 times the length? We could say twice its length. Okay, that's the numerator. Then we translate the fraction bar as divided by. And then the denominator is 2. Okay, so read these words and look at the equation again. The width of a rectangle is the quantity of its perimeter minus twice its length divided by 2. Okay? Now, there's more than one way to word these. I'm giving you one way. There might be other ways that might be acceptable. All right, let's look at one more.